Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. In today's class in our channel, we are going to discuss rolling. Okay, this rolling comes under metal forming subject. Okay, metal forming subject. So now we'll start today's class. If you have not subscribed our channel, do subscribe and like and share our channel. Okay, at the end of the class, I will give you in the description, I'll give you the Telegram link, so you can have this PDF also. So all these things it will be useful for your exam preparation. Okay, so now we'll start today's class. See friends, so this is rolling. So as our mechanical subjects, each and every member you have to thorough with the drawing. Okay, so if you are thorough with this drawing, you can recollect all the terms which are exactly related to the particular member. Okay, so if for example, if you are discussing this rolling, you should know the rolls, how the metal is passing, what are the nomenclature related to this diagram. All these things you will recollect, you can recollect it very fast. Okay, so now we'll start today's class. See, rolling is a forming operation on cylindrical rolls wherein cross-sectional area of a bar or plate is reduced with a corresponding increase in length. So these are the two rolls. So this is the top roll and this is the bottom roll. Okay, so what is happening in this roll? See, in this roll, the rolls are in contact. The rolls are in contact with the passing metal. So this is the passing metal over a sufficient distance represented by the arc L and M. Okay, see friends, you can see L and M is the arc. Okay, angle of contact, we can say this is the angle of contact and this is angle of bite. This is the angle of bite, and here mu, coefficient of friction, mu comes here. So this is mu and this is mu. Okay, we know about the coefficient of friction. The greater the coefficient of friction, more the possible reduction. Okay, so now we'll start jump into the this class. Okay, so rolling, this is about the diagram. Okay, I think all of you understood about this diagram, right? Now we'll see what are the exact things related to this diagram. So this is absolute draft delta T. So I and F. So first we have to know what is I and what is F. I is the initial thickness and F is the final thickness. Okay, so I'll repeat it once again. I is the initial thickness and F is the final thickness. So absolute draft is delta T is Ti minus Tf, and absolute elongation delta L is Lf minus Li in mm, and absolute spread is delta B is Bf minus Bi in mm, and mu, we know, coefficient of friction, right? So first we should know the relative draft RT is delta T by Ti is equal to Ti minus Tf by Ti into 100, and elongation coefficient gamma is equal to Lf by Li, right? And forward slip is Vf minus Vr by Vr into 100, and backward slip is Vr minus Vi by Vr into 100. So where Vi is initial metal speed, Vf is final metal speed, and Vr is surface or peripheral speed of rolls. Okay, and percentage age of cold work is Ti minus Tf by Ti into 100. Okay, so now we are going to face the competitive exam, and if you are understanding the subject, we are having good knowledge in this subject, any sort of question coming under this rolling, we can face it very easily, and within a small amount of time we can go for the correct answer. Okay, so from today's class, if you are discussing this rolling, you can get what is the forward slip, like any formula you may ask, or just you can ask some data is given, find the coefficient of the friction, like that. You can ask anything, you can be asked in your examination. Okay, so always you should be thorough with this subject. Now we know the percentage age of cold work, and the rolling load P can be calculated as P is equal to L into B into PM, where L is the roll strip contact length and B is the breadth of sheet, and PM is mean specific pressure. So we can write L is equal to root R into delta T, where R is roll radius and delta T is draft, that is Ti minus Tf. Okay, So this is about our rolling, and next we'll move to extrusion. Okay, so before this extrusion, I have written about ragging. Ragging is the process of making certain fine grooves on the surface of the roll to increase the friction. Okay, so this is ragging, right? Now we'll move to our extrusion force, right? So extrusion force diagram is study, right? So always be thorough with these diagrams. Okay, definitely it will help you. Anything you are a little bit confused, draw the diagram, okay, in the rough sheet provided. So immediately you will recollect all the things which is related to the particular member. So extrusion force, you can see this is the diagram, and here you can see the extruded component diameter. So this is the extruded component, okay, coming outside, right? And this is the pressure of, okay, of pressure applied, right? So like that you should be thorough with this diagram. Now we'll see what are the things related to, closely related to this extrusion force. See, px by sigma y is equal to 1.719 dB by dx plus 2x by dB. Now where px is the pressure, sigma y is the yield strength of the material, and dB is the billet diameter, and dx is equal to extruded component diameter, and x is working length of the billet. So here you can see this is the working length of the billet or the stock. So this is about the extrusion, and we'll move towards wire drawing. Okay, wire drawing. So this is the diagram of our wire drawing. Okay, and we'll come to know what are the things, how things are related to this wire drawing. Okay, see here, sigma d is equal to sigma y 1n of a naught by af, that is for ideal deformation, and sigma d is equal to sigma y into 1 plus tan alpha by mu into 1 minus af by a naught to the mu cot alpha. So that is for ideal deformation and friction, where sigma y is yield stress and alpha is die angle and mu is coefficient of friction, right? So a naught is original cross sectional area, this is a naught, and af is final cross sectional area, okay, after the drawing operation. Okay, so that's all friends. We'll stop here. Think today's class will be definitely helpful for your exam preparation. If you're having any doubts, please post in the comments box. If you need any additional information related to your exam, I will give you a reply. Okay, so if you are not subscribed, do subscribe, like and share our channel. I will provide you the telegram link in the description. Okay, and utilize this telegram link also. So you are subscribe that telegram link also, you will get all the pdfs. Okay, so that's all friends for today's class. Thank you very much. Thank you for watching.